औज़ु बिल्लाहि मिनश शैतानिर रजीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली सुब्हानल्लाहि व बिहम्दिही सुब्हानल्लाहिल अज़ीम व बिहम्दिही अस्तग़फ़िरुल्लाह अल्लाहुम्मा हसिबना हिसाबन यसीरा अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मद कमा सल्लैता अला इब्राहीम व अला आलि इब्राहीम इन्नका हमीदुम मजीद. Okay guys, my today's video is about the cycloid. So we will find the time it takes for a block of material to slide down on a cycloid. Slide down guys, not rolling. I will upload videos on rolling by repeating all these videos with rolling in my incoming videos. Okay, so we'll find the time it takes for the block to slide down on a cycloid from point A to point 0. Okay, things are as usual except that the curve, the cycloid has been parameterized in terms of Tahir angle. For Tahir angle, you can watch my video 1, 2, 3, 4. And you see R is the radius 2 meter, that I have taken 2 meter here. The radius is 2 meter. This is the radius of the generating circle that generates the cycloid. Okay, now from my previous videos, beta Tahir angle is the parameter of parameterization. So we have parameterized the cycloid in terms of Tahir angle beta. It's very natural because when we take the derivative dy by d beta, dx by d beta, and then we get dy by dx by this, blah blah blah, we get tan beta, which is very natural results. Okay, you can watch my previous video regarding this. Okay, putting the boundary release point condition from my previous videos, v square 1 plus 2 mu beta is equal to this, video 24, putting the boundary release point condition at point A 2 pi meter 4 meter where r v is equal to 0 meter per second. So c is 2 r is the radius of the generating circle, 2 minus pi by 2, r is equal to 2 meter. I will keep things in terms of r. V is equal to blah blah blah, this 2g 3 minus pi by 2 r minus 4 plus 4 mu g r beta minus r cos 2 beta plus mu sine 2 beta. It's 2 is missing here. Okay, so ds is as usual. You can watch my previous videos 21, 23, 25. You see this minus sign can come out from here. Okay, so this is minus 2 times 2 square root of 2 r times square root of 1 plus cos 2 beta d beta. So plugging in these values in my previous equation, you can check these videos, where did it come from. Okay, so the time from A to 0, let me write it down here. Okay, so the time it takes for the block to travel on the cycloid from point A to 0 is integral of A to 0 ds over dv, because ds over dt is equal to v, so you can get it from there. Okay, so when you plug in the values in this formula, ds from here, ds from here, and v from here, you get this formula, 2 times square root of 2 r 1 plus cos blah 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 blah. Okay, so either you can use the trapezoidal rule or you can use any online integral calculator to find this value. Okay, so when you plug in the value of r is equal to 2 meter here, 2 meter, you get this expression. This is beta, not in terms of x, but you can put x when you use any integral calculator. Okay, so minus times 4 times 2 square root 1 plus cos 2 beta square root 1 plus beta square root d beta is equal to minus 22.398 plus 39.24 beta plus 39.24 cos 2 beta plus 0.52 beta. Okay, so you get 2.33 seconds. So the time it takes to slide down on a cycloid from point A to point 0 is 2.33 seconds. Okay guys, when we compare this time with the rest of my previous videos, we see that cycloid is the winner so far. Why? Because it gives the least amount of time to travel on the cycloid. 2.33 seconds, less than 2.43 seconds, very close. This competition is very close with the circle. 2.43 seconds, circle less than parabola 2.67 seconds, not that close. Very wide difference. 3.54 second, hyperbola, not that close, pretty close. 3.63 inclined plane. So the winner so far is the cycloid. Okay, in my next video we will do ellipse and we will see what it gives. Subhanallah walhamdulillah wa la ilaha illallah wallahu akbar wa la hawla wa la quwwata illa billahi al-aliyyil azim. Allahumma salli ala Muhammadin wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. Thanks for watching.